Okay, continuing along with trig. The next big question that people usually ask is, or they usually comment on when we're talking about this trig stuff, is things don't always happen with a right triangle. Right triangles are good, especially if there's a square or a rectangle, you can divide it up. But they're right. Sometimes there's not always a right triangle. We could divide up a non-right triangle into a right triangle. Maybe we've had a question like that. But we've got a couple things that we can use if we have a non-right triangle. The first is the sine law. Now, this is how it shows it in our textbook. Normally when we see it, there's only one equal sign and one of these kind of fractions or ratios or divisions. But this just shows that it works for any of the sides of a triangle. Any side angle combination, side angle ratio. They will all be equal. Normally when we see it, let me just find my mouse again here, it won't have this. And when I write it, I don't have that part. So I just have something like that, sine A over A equals sine B over sine B, or A over sine A equals B over sine B, or sine A over A equals sine B over B. Now I'm saying or here. We can use the top one, or we can use the bottom one. Now the top one is mainly for because we like the missing thing on the top. So I would use this top one. I would use this top one if I'm trying to find the side. This bottom one here I would use because the angles are on top if I'm trying to find an angle. Okay? And I would just use something like this. So we'll set it up. We'll see, we'll have a question come up here. Okay, we'll pick one of these because I'm down in the one corner, and if I need a calculator, it'll show up on that right side also. Let's do A. Okay? Now, we talked about side angle combinations. Determine the length of the unknown sides of each triangle. So there's a lot of unknown stuff here. Always when we're doing it, here is one angle, and they always go with the opposite side. So this is angle Z, that is side Z. Those two go together. Okay? This angle 52 here, maybe I'll put it, I started drawing the circle, but I'll change it into a triangle. This 52 goes with the side that is opposite it, so that side Y. So as you can see there, angle Y, side Y. Okay? And the last one here, angle X, we'll put maybe this one in a square, goes with over here, side X. Now there's a bunch of stuff we got to find out in this triangle. The first one is determine the lengths of the unknown sides in each triangle. Okay, so we don't need this angle. We might in a little bit. Let's do this first though. That's just my angle side. Angle X is equal to, we know that in a triangle, all the angles in there have to add up to 180 degrees. So if we just take our calculator and we subtract those, so I'm going to turn it on here, delete this old stuff that I did, 180 minus 47, and also minus 52. That angle up there has got to be 81 degrees. So There's some information. That one was easy to find. But that doesn't help me find any of these side lengths. So the one side combination, side angle combination that we know is 17 goes with sine 47. Right? That's what I did here. The 17 inches there and the 47 degrees there. Those two go together. Now, if I can't do x because there's two unknowns here. Actually, I could use the 81 if we wanted to figure out x first. Let's do that. So I don't know the side length, but I just calculated the angle up there, and it is 81. Okay? So this looks like there's a lot going on, but it's not too bad. In order to get this x all by itself, all I have to do is times both sides, and I'm not going to be able to fit it writing it over here. Oh, I wonder if I can write off the, oh, it won't show up on there. I got to times both sides by sine 81. So when I do that, I'm going to skip that for right now just because I don't have room to do it. But if I do multiply both sides by sine 81, that's going to move it to the other side, and I can write it like this. And x will now be all by itself. So I can do this all in one step. Now, there's a trick. The reason why I wrote it like this, 17 sine 81, instead of sine 81 times 17, is because that 17 is a side length. We don't want to get it mixed in with this angle. Even when I type it into the calculator, it's got brackets around that 81. So it kind of keeps it, it automatically puts them. So I usually put the side length out front so that it's not messing it up, and it will change it. If we look on the calculator here, if I clear this, if I do 17 sine 81, and I won't put the bracket just to show, we get 16.9. If I do sine 81 times 17, I get something else. Okay? So because it's multiplying that side length and the angle, we got to keep them separate. That's what that sine word does, is it facilitates that ratio. So to calculate this, I'm going to type it in almost exactly how I have it written on there. I'm going to delete all these things here. I'm going to go 17. We can put the times, or we just saw we can just write sine 81. I may as well put it. Times sine 81. I'm going to close my bracket. Divided by sine 47. And I'm going to close that bracket too. Equals 22.95. So 22.96. Makes sense. I always look back into the question. So if I look into this question, the one side is 17 inches. Oops, I'm not going to be able to write it here. 22.96. So if we look here, this side here is 17 inches and the angle is 47 degrees. Because this is 81, I know it should be bigger than 17. So this one's 22. That's bigger than 17. So I'm going to guess that what we've done here is correct. Okay? Now we still need to figure out y. So we found x. Okay? Now we're going to find y over here. So this question has got a lot going on with it. And I kind of made it look a little bit messy here. So to find y, now that I have both pieces of information for x, I could use that if I wanted to. But if we're on a test and we're not 100% sure that we've got it right, it's always better to go back to the stuff that the question gave you. So I know that 17 and sine 47 is right because the question gave me that. Okay? So now to find y, I've got a y, and I've got sine 52. Okay? After you've done this a whole bunch, like I look at this and I kind of skip the step where I say times by sine 52, times by sine 52, and I already know that I'm bringing this sine 52 up here. So my next line I make look like 17 times sine 52 divided by sine 47 equals y equals, I've just got to do this on my calculator. Now, as I'm doing it on my calculator, one interesting thing about this sine law is it works for even non-right triangles. Or, sorry, for these are non-right triangles. It works for even right triangles. So what ends up happening is a lot of people, especially people who don't like math, get a little bit frustrated and say, well, like, why didn't you just show me this from the beginning? And I could have used this for everything. Remember, at the beginning, we didn't know what the heck sine meant. So that's why we did all that other stuff first with the sine and stuff like that. And there is one case that we'll see another day that this can't solve, which will need another law called the cosine law. But for the most part, this can solve quite a bit of stuff. So this sine law is pretty powerful. And you can solve even right triangle stuff with the sine law. So if you're ever stuck, this sine law is handy to know how to use. Okay? There was a whole bunch of find the side questions. We did find an angle, but we did it our cheat grade 9 way, I guess, by knowing that inside of a triangle it adds up to 180. So we found x, we found y, we found both of the unknown sides.